In this section of the course, we're going to talk all about how to troubleshoot video issues on a given system, including physical cabling and source selection, projector issues, and video quality issues. So, as we move into this section, we're again going to be focused on Domain 5, Hardware and Network Troubleshooting, as we fully cover Objective 5.4. Objective 5.4 states that given a scenario, you must be able to troubleshoot video projector and display issues. Now, as we begin this section, we're first going to take a look at different cabling and source selection issues that can occur, including selecting the wrong data source, broken cables, and cables that aren't properly seated into the connectors, and much more. Then, we're going to move into some different projector issues that you might encounter as a technician, such as when a projector has a burned out bulb, a dim image, or intermittently shuts itself down. After that, we'll move into our discussion of video quality issues, including fuzzy images, display burn-ins, dead pixels, flashing screens, and incorrect colors being shown on your display. As you're going to learn in this section of the course, there are lots of different video issues that you're going to encounter as a technician in the field, and you're going to be asked to troubleshoot and rectify them. So, let's get started with our coverage of how to troubleshoot video issues in this section of the course. In this lesson, we're going to talk about physical cabling and source selection issues that may cause you to have issues with your video or audio signals. Now, when we talk about physical cabling issues, this usually refers to the fact that the cables will wear down over time, especially if you connect and disconnect them repeatedly. If you're connecting to an external display using a cable that carries a digital signal, something like HDMI, DisplayPort, Thunderbolt, or DVI-D, these cables, when they fail, will completely make the signal disappear. On the other hand, if you're using a physical cable that's carrying an analog signal, something like VGA or DVI-A, these cables could deteriorate or break over time, and when they do, you'll still get a display image, but that display image will look wrong. For example, VGA cables use 15 pins that are connected to 15 individual wires inside of the VGA cable. If one of those pins or wires inside of that cable breaks, you can have issues such as the horizontal hold not being able to hold the image in place, or entire colors that will disappear, such as the red, blue, or green, since it uses a composite image using this analog signal over these cables. Now, luckily for us, these days, most of our cables are going to be used with a digital signal like HDMI, DisplayPort, Thunderbolt, or DVI-D or DVI-I, which is DVI digital or DVI integrated. All of these carry digital signals. So when these cables deteriorate, the entire signal is going to go away, and this makes it a lot easier to troubleshoot that it's an issue with that cable. If you come across a system where the display is no longer displaying to the monitor, this could be an issue where the cable is the problem. Now, when you look at the cable, there are several different things that could be the issue here. The first is that the cable itself could have been broken over time. This commonly occurs in an office environment when you're using longer cables and somebody rolls their office chair over the cable, and if this happens repeatedly, the wires inside of that cable will break, and this will cause the signal to not be able to reach the distant end, which has your display. If this occurs, the best thing to do is to physically inspect the cable, and if you notice that it is physically damaged, you would simply replace that cable. Another thing that can happen with your cables is when they're not properly inserted into the connectors or ports. Let's take the example of an HDMI connector. You need to connect that cable into two places in order to have a valid signal. One is your source, which would be the back of your computer using your video graphics card or the integrated HDMI port on your motherboard cluster. The second is into the back of your monitor or TV. Now, if the cable is not properly inserted into the port on both of those areas and is not fully seated, you're going to have an invalid connection, and the HDMI signal will not be able to move across that cable and get to the display. So if you're having display problems, you should check and make sure that both ends of the cable are properly seated into the appropriate connections. The third issue you might come across with a physical cable is that that physical cable was a cheap quality cable to begin with. In this case, you may be limited at the top speed that can be sent over that cable. And in the case of something like HDMI or DisplayPort, if you don't have the top speed, you're not going to be able to have the top resolution. For example, if you're trying to send 4K data over the cable, but you have a very inexpensive HDMI cable, it may only support 1080p instead of 4K. In these cases, you're only going to be able to get an HD image and not a full 4K image. If you're using a very high quality display or monitor, you may notice that blurriness to it because you're now using 1080p instead of a 4K image. To be able to fix this issue, you want to move up from a basic HDMI cable into a high-speed rated cable instead, which can support those higher bandwidths and be able to give you the full picture that you're seeking. For these reasons, when I'm working as a technician, I always carry a couple of spare cables with me. This way, I can simply detach the cable from the customer's computer and monitor, replace it with one of my known good cables, and verify that it's not an issue with the monitor or the video card, and instead it was just the cable. If this was the issue, we would then have to buy a new cable and replace it for that customer's computer to make sure we can get them back up and running fully, or we can leave our known good cable with them and purchase a new one for ourselves. Now, it's also important to remember that when you're dealing with a lot of these digital standards like HDMI, DisplayPort, and Thunderbolt, they can also carry audio over that same cable. So if the end user is having issues hearing the sound from the system, it could be an issue with that cable as well, and this would be another case where you'd want to replace the cable with a known good cable and see if this fixes the issue. If you're using VGA or DVI cables though, these cannot carry sound, and in those cases, the audio issue you're experiencing would be tied to the fact that they don't have a proper cable connected for the audio connection. In these cases, you want to verify that the audio cable is connected from their speakers into the back of the computer using the 3.5mm jack or the SPDIF connection if you're using a digital fiber optic connection to your audio system. Another issue you may come across is when you have the incorrect data source selected. This can happen a lot when you have a display that supports multiple HDMI or DisplayPort connections. For example, I have a 4K monitor that has 2 different HDMI ports on it and 1 DisplayPort. So it has 3 source inputs that they label input 1, 2, and 3. If I connect my computer into the HDMI port that is labeled as input 1, but I've selected input 2 or 3 on that display, I'm going to see a black screen and it's going to say missing source. In these cases, you simply need to be able to change the setting on that monitor to be able to select the right input. Normally, the monitor will have a button on it that's labeled as input, or it'll be a little square with an arrow pointing into the square that indicates this is the input selector. In these cases, simply switch to the input where your cable is plugged into, and this will be able to show the image on the display properly. Now, the final thing I want to mention is that sometimes you may have an issue when you're dealing with HDMI devices going from a computer to a TV or from some sort of a set-top box to a TV. For example, if you have a smart TV device like an Apple TV, Amazon Fire, or Roku device, and you plug it into your TV over HDMI, it actually uses a content protection system over that connection to be able to make sure that the TV and the device are authenticating to each other. This is known as HDCP, or High Bandwidth Digital Content Protection. Now, this was a type of coding scheme that was developed by the manufacturers to protect the audio and video signals that are going between the systems over HDMI, DisplayPort, and other technologies like this. The whole purpose of this system is to prevent people from being able to copy or illegally intercept the signals from a streaming video session. Now, all that being said, sometimes it doesn't work perfectly. And in those cases, you need to understand how to troubleshoot issues with HDCP. Now, the first thing I want you to do if you're having an issue with HDCP is simply turn off the TV and turn off that device, and then turn on the TV and then turn on the device. By doing this and making sure the TV is on first and then the device, it will allow the handshake to occur, and usually this will fix about 75% of the issues you have with HDCP. The other thing you can do if this doesn't work is upgrade the quality of the HDMI cable that's being used between the two devices. Again, this is an area where if you're using a very inexpensive type of cable, you can have issues because the signal is not being properly sent and there's not going to be that copyright handshake happening over HDCP properly. So, if you find that you're having this issue a lot, what you're going to want to do is replace that cable with a higher quality HDMI cable that can support higher bandwidth operations and that is made of a higher quality, like a gold-plated connector, to ensure you're getting a proper signal between the two and there's no interference during that handshaking process. Keep this in mind if you're working with any kind of set-top boxes, smart TV devices, or even game consoles, because all of these do use HDCP, and if that handshake doesn't occur properly, you're not going to be able to get it onto your display and be able to use those devices. And instead, you'll get an error saying HDCP error, the device you're trying to connect is not authorized for use on this system. So remember, when it comes to display issues, usually this is going to come down to one of two main areas. It's either going to be a physical cabling issue, such as the cable is of low quality or not properly seated into the connections, or you've selected the incorrect data source on the display, and therefore it's looking on input 2 or 3 instead of input 1 and showing the wrong image or no image if nothing's connected to those ports on the display. In this lesson, we're going to talk about projector issues. Now, a projector is a special type of display that is normally used in large environments when you're trying to share an image across an entire room for everybody to see. For example, if you think back to when you went to school, you probably had a projector in that classroom. This allowed the teacher to share their computer screen so everybody could see it across the entire room. When you're using a projector, often these will be either a portable projector or a permanently installed projector that's installed from the ceiling, and therefore there's cables running from that projector through the ceiling, down the wall, and into a wall jack, usually using something like HDMI or DisplayPort. Now, when using a projector, especially one where the cable is going up and through the walls, you do have to make sure that the connectors are properly connected between your system and that projector. If anywhere along that connection, from the back of the projector all the way down the wall and then into your computer, is broken, missing, or not properly connected, this will cause the projector to not be able to display the image from your screen. So you need to make sure you're always looking at all the cabling from a physical standpoint to make sure it's working properly. Now, in addition to the physical cabling issues with projectors, there are 3 other issues that you may come across when you're trying to support projectors in a classroom or conference room environment. These include dim images, no images, and the projector shutting itself down intermittently without any warning. Now, first, we're going to talk about dim images. When you're looking at an image and it looks very washed out or dim, normally this is an issue with the bulb reaching the end of life. As the bulb in the projector starts wearing down over time, it's going to get less and less bright. So when you have a brand new bulb, it's going to be very bright. Maybe it's going to be 3,000 or 4,000 lumens. But over time, it's actually going to dim down just like a light bulb. Now, this dimming is your warning that it's time to start replacing that projector bulb. Otherwise, it could end up failing completely. Now, when the projector bulb fails completely, there's going to be no light, and therefore, you cannot send the image from the projector to the big screen across the room. This is what we call a burned out bulb. In either of these cases, you want to replace the bulb on that projector. Now, when you're dealing with projector bulbs, these are usually rated in hours, and these can be anywhere from 500 hours to about 2,000 hours, depending on the make, model, and brand of the bulb and the projector. So, if you've been asked to help select a projector, this is one of the factors you want to consider when buying a projector. Some projectors are going to be lower cost, but they're going to have a shorter bulb life as well, and this means you're going to be changing out that bulb much more often. And these bulbs are not cheap. They can range anywhere from $50 up to $500 or more, depending on the make, model, and brand of that projector. So it is something you want to think about ahead of time as you're picking out the projector you want to use in your classroom or conference room environment. Now, because these projector bulbs are measured in hours, there's actually a counter on the projector that's going to count up how many hours that bulb is being used. This will allow maintenance staff to go in there once a week or once a month and check the status of that counter. So if you look at the projector and it says you're at 450 hours and you know that normally this is a 500-hour bulb, you want to make sure you order a new bulb and have it on hand so you can replace that as it gets up to 500 hours or when it fails. Now, once the bulb starts reaching its end of life, it will start dimming, as I said. But normally, once it starts dimming, you'll probably still have about 50 to 100 hours worth of use. This would be a great time to ensure you have an extra bulb in stock so that if and when that bulb fails, you can replace it, or you can preemptively replace it once the bulb starts dimming to make sure everybody's getting the brightest and clearest image possible. Now, once that bulb burns out completely, it is going to go completely dark, and at that point, you must replace it to be able to bring the image back. When you're replacing one of these bulbs, many of them are actually very sensitive to our hands and the oils in our skin. So you want to make sure you're using a glove, not necessarily to protect yourself, but to protect the life of that bulb, because the oils in your hand can break down that bulb and cause it to have a premature end of life faster than it normally would. And again, these bulbs are expensive, so you want them to last as long as possible. In addition to wearing gloves to protect yourself when handling the bulb, you also want to make sure you allow the projector time to cool down before you try to replace the bulb. These bulbs can get to be extremely hot, and so if you try to remove the bulb right after you turn off the projector, you will end up burning yourself. So you want to make sure you let it cool down for at least 15 to 30 minutes before trying to remove that bulb. That way it has time to cool itself down naturally and you can touch it safely without burning yourself. Now, the other major problem you may have when dealing with projectors is that sometimes they will just shut down or restart all by themselves. This problem is very similar to your computer when it shuts itself down to protect itself from overheating. And that's usually what the cause is when a projector is intermittently shutting itself down without giving you any warning. Generally, these projectors are going to heat up because of that really hot bulb, and they have cooling fans that are there to be able to start dissipating that heat. But if you have the projector hanging from the ceiling, most of the time, people don't think to actually clean out those air vents on the projector, and this can lead to the projector's fans getting clogged with dirt or dust and making them overheat. So, if you start having a projector that is intermittently shutting down on you for no reason at all, most of the time it's because it's overheating. In these cases, you want to check the projector's fan and make sure it's working, and make sure that its air vents are properly cleaned and clear of any dust or dirt or debris to be able to make sure that the airflow is going through that projector properly and cooling down that system. Now, if you go and look at that projector after it's shut down and you've noticed that the fan was working and that the airflow is being able to go through it properly because it has clean vents, then it may be a different issue. And in this case, usually it's going to be that the projector didn't detect a source input. If the projector doesn't get a source input, most projectors will shut themselves down after 1 minute, 2 minutes, or 5 minutes, depending on how it's configured. The manufacturers have configured these projectors to do this automatically in order to save more of the bulb's life by turning off the projector and saving that. This also helps with energy savings because you're not using electricity if the projector shuts down. So, if the projector is shutting down after 1 minute, 2 minutes, or 5 minutes, and it's always the same amount of time, generally this is going to be because of the setting inside of the projector and the projector is not identifying the source. But if you were using the projector and you had a valid picture on the display and it shuts itself down, most of the time this is going to be an overheating issue, and you're going to need to go back and make sure that all the systems are working properly and that the projector is getting adequate airflow to keep itself cool. Fuzzy images. That's right, some of our displays will have a fuzzy image, and normally this happens when the output resolution that's being sent from the computer is lower than what the display can actually use. For example, if you have a computer monitor that's capable of doing 4K or 8K displays, but you're only sending it a signal at 1920 by 1080 pixels, this is a lower resolution than they can support, and your image is going to look blurry. This is because it has to take that smaller amount of pixels and spread it out across a larger screen that has a higher pixel density. And so, that 1 pixel may now be 4 pixels when it's displayed, and that gives you that blurry or fuzzy image effect that we're talking about. To fix this issue, you simply want to change the output resolution from your graphics card to make sure it's giving what the monitor is expecting. Another thing to keep in mind is that every type of display has its own default resolution that it's designed to support. Now, you can use one that is lower or higher than this, but in those cases, it has to scale up or scale down to match its default resolution. So, if you have a monitor that by default will support 1920 by 1080 pixels, and you send it an image that's only 1280 by 720 pixels, this is going to require that smaller resolution to be stretched out across that 1920 by 1080 pixels to fill the entire screen. Instead, if you send it at the default resolution, you're going to see a much clearer and crisper image than if you sent a lower quality image that now has to be scaled up across that larger pixel density of 1920 by 1080 pixels on your computer monitor. Another issue you may come across is flashing screens. Now, when you're looking at a display and you have a flashing screen, normally this means that the cable is not properly seated into the connector. Because of this, you're intermittently getting the picture and then it's going away again. This is one of those things that happens because we're using digital signals over a cable. And if the cable is not properly seated and it's wiggling inside the connector, this can cause the connection to go on or off, and this causes that flashing image on the screen. To solve this, check the cable, make sure it is properly seated, and if you find that the cable was properly seated and you're still having this issue, I recommend you change out that cable for a known good one and see if that solves the problem. The next issue we have is what's known as dead pixels. Now, when we're dealing with LED and LCD displays, these are made up of pixels. And on your screen, if you see a dead pixel, this means you have a pixel or picture element that is no longer lighting up. So, if you're looking at your entire screen, you have lots and lots of pixels. But if you start seeing one spot that is always black or always dark, this means you have a dead pixel on the screen. One of the best ways to troubleshoot this is to take your mouse cursor, which is normally white, and place it over that spot on the monitor. If you now see that there is a black spot inside of that white cursor, this is a good indication that you have a dead pixel. Now, unfortunately, there is no fix for a dead pixel. You can't actually solve that dead pixel and replace it. Instead, you have to replace the entire display. If it's on a laptop display, this means you're going to actually have to take apart the entire laptop, buy a new display, and then install it. If you're using a desktop computer, this is a lot easier because you can simply replace your monitor. Now, most people will not replace a monitor over a single dead pixel, but once you have one dead pixel, usually you're going to start seeing more pop up over time, and when that happens and it gets too annoying, that's when you're going to want to replace the display. Now, another display issue you may come across is what's known as burn-in. Now, burn-in occurs when you have the same static picture being displayed for a very long time on a particular screen or display. For example, if you've ever gone into a sports bar or restaurant that always has a certain TV channel on, that watermark logo in the upper right corner will actually burn in, and when you turn off that monitor, you're still going to see the logo from that TV station in the upper right corner because it is now part of that display permanently. This is sometimes referred to as a ghost image or a burnt-in image. Either way, it becomes now permanently part of your display, and the only way to solve this is to actually replace that display. When it comes to displays for computers, the most susceptible to this are plasma screens, which are an older technology, or OLED, or organic LED displays. If you're using a TFT or LED display instead, they're not nearly as susceptible to burn-in. To be able to prevent burn-in, you're going to use a screensaver or some sort of an animated thing that's going to move on the screen and make sure you don't have something static on your screen at all times. Another thing you can do is set your display to turn off after 3 to 5 minutes of inactivity. This can help prevent burn-in, and it will also save you energy. The final issue we're going to talk about is incorrect color displays. Now, when you're dealing with a computer's display, there are several different things that can go wrong and cause you to have the incorrect colors being displayed. Now, the biggest one is if you have the wrong color bit set. Now, what I mean by color bit is the actual amount of colors that can be displayed on a given monitor. This is normally referred to by the number of bits that make up the color palette. For example, if you have an 8-bit color palette, this means you have 256 different options because you have 2 to the 8th power of color options. If you're using a 16-bit color display, this means you have 32,768 colors that could be represented on that screen. If you're using a 24-bit color display, we call this a true color display. And this means you can have 16,777,216 color variations, which is 2 to the 24th power. Now, the final one we have is what's known as a 32-bit color display. Now, if you have a 32-bit color display, this is what we refer to as a deep color display, and this has over 1 billion different color options. This makes it so you can have lots of different choices. Now, most people with the naked eye can't really tell the difference between a 24-bit display and a 32-bit color display because we're talking about 16 million versus 1 billion different color combinations. But you will definitely see the difference if you go down into a 16-bit or an 8-bit display. It is extremely obvious. So if you have the wrong color depth setting, you're going to have a lot less colors, and you're going to be able to notice this really easily on the display, and you'll be able to see that this has an incorrect color to it. Now, the other thing that might go wrong with color displays is what's known as the color profile. If you select the wrong color profile in your system settings, this will actually display colors differently based on that color profile. For example, there are a couple of main color profiles that are usually used by people, including the Adobe RGB, the sRGB IEC version, and Display P3. Now, for most of us as the average user, you probably aren't going to be too particular about the color profile you're using, but if you are working in graphics, design, video editing, or things like that, you really need to make sure you're using the same color profile as the other people in your work environment, because otherwise, if your computer is set to Adobe RGB and your coworkers is set to Display P3, you're both going to be seeing the same file with different colors because there's different shading and different displays based on these color profiles. So you need to keep that in mind as well, especially if you're supporting some kind of a company that does artistic works like game studios, printers, publishers, video editors, graphic designers, and things like that. So remember, when it comes to video display issues, there are lots of things that can go wrong, including dim images, fuzzy images, flashing screens, dead pixels, burn-in, or incorrect color displays being used, and you're going to be expected to troubleshoot and fix all these different issues in the field.